faithfully delivering value and interpreting great books from around the world. Hello, this is Sally's Book Club. Today we're interpreting How to Avoid a Climate Disaster by Bill Gates, the former world's richest man and Microsoft founder. Gates' interest in climate issues traces back to his philanthropic work. In 2000, Bill and his wife Melinda established a philanthropic foundation initially focused on global health and education issues. As the foundation's work deepened, Gates visited regions like Southern Africa and India. He gradually realized climate change was becoming humanity's greatest threat. Facing disasters like hurricanes and rising seas, the most vulnerable are those in impoverished areas. With firsthand experience, Gates began studying climate science. The billionaire advantage? He could directly consult top scholars in any field. After years of research, Gates developed his own climate change insights. Gates bluntly states, COVID's terrible, but climate change? Probably worse. He estimates unchecked climate change could cause 75 deaths per 100,000 people by 2010.
5 times deadlier than pandemics, with economic damage equal to a COVID-level crisis every decade.
Merely reducing emissions isn't enough to stop global warming. The only reasonable goal? Achieving zero carbon emissions. Zero carbon means balancing emissions with absorption through methods like reforestation, making net atmospheric carbon increase near zero. Gates explains why zero carbon is essential, the challenges involved, and potential solutions. We'll explore these three angles in this interpretation. First, why must we achieve zero carbon emissions?
Because humanity simply can't bear the dire consequences of carbon emissions.
Let's see step by step how carbon emissions are pushing humanity to the brink. Starting with the first step, carbon emissions cause the greenhouse effect. The greenhouse effect refers to solar energy reaching Earth, where some energy radiates back to space, but part gets absorbed by greenhouse gases, gradually warming the atmosphere. CO2 is the primary greenhouse gas, but others are surprisingly potent too. For example, methane has 20 times the warming potential of CO2. We use CO2 equivalent to quantify different gases' greenhouse effects, meaning how much CO2 would cause similar impact. Using this conversion, we reach a conclusion. Global annual greenhouse gas emissions total about 51 billion tons of CO2 equivalent. What does this number mean? The Amazon rainforest, Earth's lungs, absorbs just 1 billion tons annually, meaning we'd need 50 Amazons to absorb our carbon output. Worse than the volume? These gases persist for millennia. Even after 10,000 years, 20% of today's CO2 remains. So, greenhouse gas accumulation follows a sharply rising curve.
That's why even 99% emission cuts won't prevent climate catastrophe.
Climate change is like slowly filling a bathtub. Even a trickle will eventually overflow it.
When it overflows, disaster strikes.
To prevent overflow, we must shut off the tap, achieving zero carbon emissions. For the foreseeable future, Earth will remain in a warmed state. So what impacts will this warming bring? Step 2. Greenhouse effects trigger water scarcity, extreme weather, crop failures, and more. Even minor global temperature rises cause severe problems. For instance, modeling shows the difference between 1.5 degrees Celsius and 2 degrees Celsius warming isn't 33% worse for water resources. It's nearly 100% worse. Compared to a 1.5 degrees Celsius temperature rise, a 2 degrees Celsius rise would double the number of people facing water scarcity. In reality, this warming is already happening. Compared to pre-industrial times, global average temperatures have risen by 1 degree Celsius, with some regions exceeding 2 degrees Celsius. The most prominent feature of global warming is the increase in extremely hot days, as illustrated by Albuquerque, USA, in the book. For example, in 1975, Bill Gates founded Microsoft here. Back then, the city averaged over 30 days per year with temperatures above 90 degrees Fahrenheit, which is about 32 degrees Celsius. However, By mid-21st century, the number of hot days in this region is projected to increase to 3 months annually. The extra heat from warming triggers ripple effects. Rising temperatures cause more moisture to evaporate from soil into the atmosphere, which then falls back as rain or snow. This will create worldwide climate polarization, some areas dying from drought while others drown in floods. Some places will experience increasing rainfall with massive storms becoming routine. In other regions, droughts will grow increasingly severe. Dry land and vegetation fuel worsening wildfires, while climate change directly threatens global food security. For instance, corn, one of humanity's staple foods, is highly temperature sensitive. By mid-21st century, climate change may cause 50% reduction in corn yields across southern Europe. In impoverished areas where food is already scarce, estimates suggest climate-related crop failures could drive food prices up over 20%. These compounding factors reveal the ultimate crisis. Climate change will deliver catastrophic blows to underdeveloped regions. This devastation will inevitably impact all humanity. People in underdeveloped regions emit the least greenhouse gases yet suffer most from climate change, compounded by weak infrastructure and low disaster resilience. From 2007 to 2010, Syria endured its worst drought in history, displacing 1.5 million people. Bangladesh now faces frequent massive floods that often submerge a quarter of its land. In these inundated zones, crops fail completely and residents are displaced. In 2017, Hurricane Maria devastated small Caribbean nations. In Puerto Rico, the hurricane destroyed massive infrastructure and power systems, setting the nation's development back by 20 years. Is climate change only an underdeveloped nation issue? Absolutely not. We all share this global village. One region's disaster can ripple worldwide. The most direct impact: warming melts glaciers and raises sea levels. Current trends suggest a 5% chance of 2-meter sea level rise by 2010. By 2100, losing 1.79 million square kilometers, including Shanghai and New York, displacing nearly 200 million coastal residents. If 80-year projections feel distant, consider Africa's recent locust plague. In 2020, warmer temperatures and increased rainfall in Kenya created ideal breeding conditions, triggering East Africa's worst locust outbreak in decades. Locusts ravaged over 20 African or Asian nations, affecting 20+ million people. No country remains untouched by climate disasters. We must act, but it's incredibly difficult. Ooh. Part 2 examines challenges in achieving global zero carbon emissions. First, humanity hasn't reached consensus on zero carbon. Frankly, everyone's talking past each other, different perspectives, different national interests. Some argue climate's changing but not worth massive investment. Focus funds on health and education for future generations. Others claim climate issues are bad, but we're already doing enough. Solar power and green tech make current efforts sufficient. Gates firmly disagrees with such views. He believes climate disasters will devastate the next generation unless we achieve zero emissions. Though we have some solutions, they're insufficient. We can't even curb emission growth. According to UN Environment Program estimates, maintaining current policies could push global emissions over 60 billion tons of CO2 equivalent by 2030. What? Another barrier to zero carbon? Our deep dependence on existing technologies leaves little incentive to adopt green alternatives. Modern society runs on fossil fuels: coal, oil, gas, which aren't just energy sources but vital industrial feedstocks. Steel and cement production require coal. Plastics originate from oil. Clearly, these underpin our daily lives: food, clothing, shelter, transportation. Just consider oil. Global daily consumption exceeds 4 billion gallons. Such massive energy demands can't be abandoned overnight. Fossil fuels dominate because they're dirt cheap. Hard to believe? Oil's cheaper than cola? Let's do the math. One barrel holds about 160 liters. In May 2021, Oil cost approximately $60 per barrel, roughly $0.35 per liter, or 2.4 yen. Meanwhile, a liter of cola costs 6 to 7 yen. This low price stems from massive reserves, easy transport, and mature global supply chains perfected through decades of tech investment. While great for living standards, this dependence spells disaster for climate, making decarbonization brutally hard. Outdated policies also hinder national zero-carbon efforts. Most regulations were drafted without considering climate change, targeting other issues instead. Take America's Clean Air Act, its flagship air quality law, which barely mentions greenhouse gases since its 1970 inception, focused on health hazards, not rising temperatures. Trying to cut emissions with such outdated laws is like running modern games on a 20th century computer, doomed to fail. If we total all current U.S. environmental policies' impact on carbon reduction, they'd cut 300 million tons of greenhouse gases by 2030, just 5% of U.S. emissions, highlighting the lack of consensus, slow tech transition, and outdated policies. These combined factors make humanity's zero-carbon path extraordinarily difficult. Fortunately, knowing the problems lets us target solutions and clear obstacles from the zero-carbon journey. So what solutions does Gates propose in Part 3?
First, build consensus and set goals. Second, establish evaluation criteria.
Finally, plan zero-carbon pathways through economic, technological, and policy angles. For consensus, we at least need shared targets to collaborate. Gates's solution is direct. Make eliminating 51 billion tons of greenhouse gases annually our ultimate goal. With this benchmark, discussions gain concrete context. For example, Europe's carbon trading scheme reduces airline emissions by 17 million tons yearly. Dividing that by 51 billion shows it covers just 0.03% of global emissions.
Gates personally invests in green tech companies.
His key investment criterion: the technology must reduce global emissions by at least 1% when scaled globally. Beyond overall goals, we need standards to evaluate new solutions. Thus, Gates introduces green premium, a core concept in this book. It measures the price difference between eco-tech and existing alternatives. Example, regular jet fuel costs $2.22 per gallon versus advanced biofuel at $5.35, making the green premium $3.13 per gallon. Choosing eco options always carries costs. Green premium quantifies that cost. Lower green premiums mean easier adoption. Higher premiums indicate greater economic hurdles. Once calculated, green premium lets decision-makers weigh implementation trade-offs. For example, if governments promote low-carbon green cement, how much burden would new policies place on supply chains, and what extra costs would taxpayers bear? Calculations show green cement's premium is double regular cement. Knowing this cost helps decision-makers budget appropriately for implementation. Green premium isn't just cost analysis, it signals which fields hold future promise. Regarding climate change, Gates argues it brings disaster but also immense opportunity. Which fields should scientists research? Where should investors put their money? Which products will be more competitive? The answers point to sectors with high green premiums. Zero-carbon industries will undoubtedly lead the global economy for decades.
Massive markets like China and the US intensely demand affordable zero-carbon tech.
Develop a product that slashes green premiums? Prove it, and you could deploy it affordably worldwide, making fortunes. That's the ex-world's richest man's logic. Of course, Gates admits green premium isn't perfect. Its calculations rely on assumptions. Some find reasonable, others dispute based on expertise. So, while not fixed, an imperfect tool beats having none. With goals and standards set, we can build frameworks for zero-carbon transitions across industries. Gates details sectors in his book: electricity, manufacturing, agriculture, transport. For this interpretation, we'll analyze electricity. It's a major emitter, producing 27% of greenhouse gases through generation and transmission. Electricity underpins all sectors. Only zero-carbon power enables decarbonizing manufacturing, transport, and more. All right, let's examine electricity's current state. Simply put, fossil fuels dominate power generation: coal, oil, natural gas, etc. Globally, coal generates 40% of electricity, while oil and gas contribute 25%. These ratios barely changed in 30 years, while fossil electricity prices kept falling. In the US, 2000's electricity cost just 125th of 1900's prices, with power sector spending at only 2% of GDP. Considering our dependence on electricity, this is remarkably low, all thanks to cheap fossil fuels. We've perfected fossil power technology, pushing efficiency to its limits. The US government actively maintains fossil fuel prices to ensure stable, affordable electricity. Cheap prices, mature tech, policy support, these factors make decarbonizing power exceptionally difficult.
Gates' solution addresses economic, technological, and policy angles. First, economics. Let's examine electricity's green premium.
Zero-carbon sources include wind or solar and fossil plants with carbon capture. What's their green premium? Converting all U.S. electricity would add 1.3 to 1.7 cents per kilowatt hour. For average households, that's around $18 monthly, about one meal's cost. Why such low premiums? Solar and wind costs plummeted over the past decade. 2020, solar panel prices were just 1/10 of 2010 levels. Growing demand enabled mass production and tech refinement, driving prices down. Currently, solar and wind power provide 7% of U.S. electricity. Seems like good news. The low green premium might enable clean energy to replace fossil fuels. But it's not that simple. Reliability is the biggest bottleneck for solar or wind adoption.
First, sunlight and wind are unevenly distributed. Abundant sometimes, scarce others.
The sun rises and sets daily. Wind doesn't blow constantly. Raising solar and wind share too quickly risks frequent blackouts. Some suggest storing excess power during sunny or windy hours with batteries. True, that's one solution. But adding storage increases the green premium.
For solar, Gates estimates nighttime power with storage costs twice daytime rates.
Meaning storage doubles electricity costs. So unless we get cheaper batteries, who'd pay $2 for $1 worth of power? Beyond timing issues, geographic limitations exist. Not all regions suit solar panels or wind farms. Achieving 100% green energy requires transporting clean power from production sites, for example, the equator, to demand areas, for example, cloudy regions, meeting new transmission lines. And more transmission lines inevitably raise electricity prices. In fact, transmission or distribution costs exceed 1/3 of final electricity prices. So despite low base green premiums, solar and wind's spatiotemporal unevenness makes widespread use problematic and costly, impossible for 100% clean energy. And that's Gates's economic analysis conclusion via green premium. Of course, this analysis doesn't provide concrete solutions. Decarbonizing power requires combining technology and policy approaches. And technologically, current methods fall short. We need revolutionary breakthroughs. On one hand, with relatively cheap, high-performance batteries, we could boost solar and wind power's share significantly. But for lithium-ion batteries, like those in EVs and phones, major performance breakthroughs are nearly impossible. After 30 years of development, these batteries only improved 3 to 4 times and are hitting physical material limits. Meeting a city's energy storage demands requires entirely new design approaches and tech. Gates mentions brilliant inventors he knows are developing liquid metal batteries. This liquid metal enables rapid storage and delivery of greater energy. This tech shows early promise for city grid storage. Plus, we need more advanced new energy sources. In the book, Gates lists promising clean tech like hydrogen and geothermal.
Among these, Gates champions nuclear. It's our only proven 24/7 reliable power source.
Nuclear plants work almost anywhere globally, and crucially, they've proven scalable. France gets 70% of its power from nuclear. No clean rival comes close. But nuclear has clear downsides: sky-high construction and maintenance costs, and safety fears. Shadows of Chernobyl and Fukushima still haunt public perception. Gates argues we can't abandon nuclear over risks, just like we added seatbelts to cars instead of banning them. Without expanding nuclear, hitting zero-carbon electricity is nearly impossible, and tech keeps advancing. Gates invested in a company designing reactors that slash nuclear waste, run autonomously to prevent human error, and avoid overheating, dramatically boosting safety. New energy sources plus high-performance batteries could slash clean electricity's green premium, finally beating fossil fuels. For electricity to advance these new technologies, governments can't stand idly by. First, governments must increase investment in new technologies. Gates estimates we need at least a fourfold increase in clean energy R&D funding over the next decade. And currently, global clean energy research investment totals $22 billion annually. That's just 0.02% of global GDP. Energy companies spend only 0.3% of revenue on R&D. Compare that to electronics and pharma industries investing over 10% of revenue. To bridge this gap, governments must lead investment while creating policy incentives to attract corporate R&D. This creates a virtuous cycle. Once research shows promise, private investors will take the baton. Additionally, governments must level the playing field. Most zero-carbon tech carries higher costs due to green premium. This happens because fossil fuel prices don't reflect environmental damage costs, so fossil fuels only appear cheaper. Thus, governments must price carbon, charging for emissions, making polluting tech more expensive. This shouldn't be punitive, though. Rather, it should incentivize manufacturers to develop lower carbon products. Gates offers these policy recommendations, not just for electricity, but most decarbonization sectors. Note, Gates's analysis reflects current U.S. policy environments. By contrast, China leads globally in clean energy investment and policy support. Examples include subsidizing green enterprises and establishing carbon trading markets, showcasing China's climate commitment. Ultimately, economic analysis directs, tech innovation enables, and policy support sustains. All three are essential for industrial decarbonization. So as individuals, what can we do for energy conservation? For example, choose technologies and products with low green premiums. Consider electric vehicles or plant-based burgers. In daily life, individuals can contribute to emission reduction too. Though the road ahead is tough, we needn't despair. We've identified obstacles and potential solutions. As Gates concludes, I'm encouraged by the passion I see for tackling climate change. By focusing on zero emissions and diligently executing plans, we can avoid disaster, lift millions from poverty, and protect our planet for future generations. We must believe in humanity's power. This concludes our interpretation of how to avoid a climate disaster. Reading notes are below the audio. See you next time.